Inside each of us, there is a universe. It sits quietly in the dark, protected by our skull. This is the brain, a soft and warm organ, weighing only a few pounds. It seems small for the immense power it holds. Yet within its gentle folds lies a world of incredible complexity and life. This is not a simple machine of gears and levers. It is a living, breathing landscape, a city that never truly sleeps. The citizens of this city are billions of tiny cells, each one a spark of potential, working together to create everything we are and everything we know. Let us look closer at a single citizen of this inner city, the neuron. If you were to see one, you might think it looks like a strange, microscopic tree. It has a central body, like a trunk, and from this body extends a web of delicate branches. These branches, called dendrites, reach out into the space around them, listening for signals from their neighbors. They are the ears of the cell, constantly waiting for a message to arrive. The neuron is a patient and attentive listener, existing in a state of readiness, prepared to play its part in a larger conversation. From the other side of the neuron's body, a single long fiber extends outward. This is the axon. It acts as the cell's voice. It is much longer than the dendrites, sometimes stretching across vast distances within the brain. The branches of the neurons do not actually touch. Where the axon of one cell meets the dendrite of another, there is a tiny, infinitesimal gap. This microscopic space is called the synapse. It is a place of immense importance. The message must make a leap from one cell to the next. The synapse is the junction box, the transfer point where information passes hands. The entire brain network is built on these countless trillions of connections, small gaps where communication happens. When the electrical pulse arrives at the end of the axon, it cannot simply jump across like a spark. The signal must change its form. The arrival of the pulse triggers the release of tiny chemical messengers. These special molecules are called neurotransmitters. They are held in tiny sacs at the tip of the axon, waiting. When the pulse arrives, these sacs fuse with the cell wall and release their contents into the synaptic gap. A cloud of messengers floats across the divide toward the next cell. The neurotransmitters drift and bind to receptors on the receiving neuron. This incredible city of neurons cannot run on electricity alone. It is a living thing, and like all living things, it requires a constant supply of energy and resources. This vital support is delivered by the bloodstream. A complex network of arteries, veins, and capillaries weaves its way through every part of the brain, ensuring that no cell is ever left wanting. The arteries, shown as glowing red vessels, carry fresh, oxygen-rich blood from the heart, delivering the fuel the brain needs to function. It is a life-giving river, pulsing in a steady, reliable rhythm. The brain is an incredibly hungry organ. Although it makes up only about 2% of our body weight, it consumes around 20% of our oxygen and calories. The outermost layer of the brain is a thin sheet of neural tissue called the cerebral cortex. It is famously wrinkled and folded, a feature that allows a very large surface area to be packed inside the limited space of the skull. If you were to flatten it out, it would be about the size of a large dinner napkin. This highly folded surface is the seat of our most advanced cognitive functions. It is where conscious thought, complex planning language, and our perception of the world are born. The cortex is the brain's great command center, the thinking cap that defines so much of our human experience. The cortex is divided into different regions, or lobes, each specializing in different types of tasks. At the very front of the brain lies the frontal lobe, home to the prefrontal cortex. This area is our internal chief executive. It is where we make decisions, solve problems, and plan for the future. Beneath the folded surface of the cortex lie older, deeper structures that govern some of our most fundamental functions. Tucked away in the temporal lobe is a small, curved structure called the hippocampus. Its name means seahorse. It vaguely resembles one. This region is absolutely vital for the formation of new long-term memories. When you learn a new fact or experience a significant event, the hippocampus is hard at work, encoding that information and preparing it for storage. It is the brain's librarian, carefully cataloging our life's experiences so they can be recalled later. Memory itself is not stored in a single place like a file in a cabinet. Instead, a memory is a specific pattern of connections spread across a wide network of neurons. When we recall something, the face of a loved one, the melody of a song, the brain reactivates that specific pattern. The hippocampus helps to initiate this reactivation, calling forth the memory from the distributed network. Movement is controlled by another specialized area of the cortex, known as the motor cortex. When we put all these pieces together, the neurons, the synapses, the specialized regions, we begin to see the brain for what it is, a living supercomputer. But it is unlike any computer we have ever built. Its processing power comes not from a single central processor, but from the coordinated activity of billions of simple units working in parallel. A single thought is not confined to one place. It is a wave of activity that can travel across multiple regions, lighting up vast networks of interconnected cells. These functional networks are the true source of the brain's power. The most remarkable feature of this biological computer is that it is not static. Its wiring is not fixed at birth. The brain is constantly changing and reorganizing itself based on our experiences. Modern science has given us extraordinary tools to peek inside this living world. Technologies like functional magnetic resonance imaging, electroencephalography allow us to watch the brain in action without ever being invasive. While they don't show us individual neurons firing, they reveal the larger patterns of activity. They show us the symphony of the brain, the rise and fall of energy in different regions as we think, feel, perceive. These tools translate the silent, electrochemical work of the brain into images we can understand. For our journey, we imagine an even more powerful view. As our journey comes to a close, we pull back for a final wide view. We see the whole brain glowing softly in the darkness. We see the individual sparks of light, the tiny synaptic flashes, and they combine into great waves of activity sweeping the organ. From the smallest scale to the largest, we have witnessed an interconnected system of breathtaking elegance and complexity. The tiny chemical leap between two cells links to the grandest of human thoughts. To look upon the brain is to be filled with a sense of awe. Let this image of the glowing brain stay with you,